So by now we should be used to looking at how transformations affect base graphs. Last lesson we looked at the base graph of a logarithmic function which looks like this: vertical asymptote at x equals 0 and a slow and steady growth from left to right. Okay, so how do transformations affect the base graph? What I thought we might do is have a look at Desmos and quickly go through the different transformations, both vertically and horizontally, and make a little chart about what gets affected so that you get a sense of where you need to sort of devote your energies for sketching. So we'll do that in this video, and then the next video we'll have a look at a few quick examples, and then that'll be it for that. So here we go. There's our base graph there. We've got a vertical asymptote at x equals 0. You can see it's dotted in there. And I've got a purple line here to say y equals log x, so looking at the base 10 graph again. And to start off with, let's look at vertical translation. So I'm going to add n to that. So when n equals 1, what's happened to the base graph? The base graph is now, so the base graph is in black here. And we can see that in the purple here, the purple line has gone up a unit, just like we'd expect, because every single point has just had n added to it. So as I increase n, it goes up. If I decrease n, it goes down, like so. The graph itself is the same shape, and it doesn't change the vertical asymptote at all. But we can see that the one other point will go up and down because every point has been translated by n units up or down. And that will therefore also affect the x-intercept as well, like so. So if I go n equals -1, so we've got log x of -1, we can see now that it's at x equals 10 for y equals 0. So what does that mean? We've got the asymptote is not affected. The x-intercept is affected. There is no y-intercept, and the other point is affected. Okay. Horizontal translations. We know that means a translation of the input, which means that instead we are going to be putting n in here. We know that we just reverse the sign there, so it's x minus n. And we're going to have a look at the point 10 minus 10 as well. Oops, accidentally deleted that. That's annoying, isn't it? Just quickly add it in. 10 and log of 10 minus whatever the value of n is. Okay. So we'll go back to the base graph. In this case, we'll have n equal to 0 for the base graph. So they're both exactly the same. As I increase n, it goes to the right because we're subtracting n here. As I decrease it, it goes to the left as you expect. It looks like it's stretching, but it's not. And to sort of illustrate this, I'm going to move the vertical asymptote as well. And you'll see now that it is simply just shifting across, like so. So it's the same graph, but the asymptote has just shifted it to the left or to the right. This will, of course, affect the x-intercept, and if I make n negative, we'll suddenly have a y-intercept as well. Okay? So what's affected? Pretty much everything, isn't it? So the x-intercept will change. The other point will change. Yes, if n is less than 0. The asymptote changes as well. So everything changes with a horizontal translation. Let's have a look at a reflection. So we know a reflection is just positive or negative, so I'll just reset that back to 0. We'll get rid of n, like so. We'll get rid of n here. Okay, so what happens if we do a reflection about the x-axis? Then it just flips that way. So it's exactly the same. The asymptote hasn't changed, the x-intercept hasn't changed, but the other point does. So back to our graph, back to our table. The asymptote does not change. The x-intercept does not change. There is no y-intercept. The other point has changed. Okay, let's do a reflection about the y-axis. So that would mean that's a transformation of the input. So it would mean log x becomes log of negative x. There we go. We can see that the vertical asymptote hasn't changed. We can see that the point log of negative 10 has been affected, hasn't it? So we do have a bit of an issue here. Just hold on a sec. Yeah, sorry, I just had to pause the video while I worked out how to explain this best to you. This point won't show up now because there is no log of negative 10. So I need to explain to you just without looking at the reflection here, and that is that it doesn't exist the graph doesn't exist on the right-hand side now because all positive values of x are made negative and the log of a negative number doesn't exist. It only exists on the left because, say, if the input of negative 10 is then made negative 10, which is positive 10, and the log of 10 is 1. So there's the point there. So that's basically what's happening. It's reflected about the y-axis. It looks exactly the same. So what does that mean? It means that the coordinates of the critical point or the other point have changed, but the asymptote hasn't changed. And it also means the x-intercept is made negative as well. So what does that mean? The asymptote has not changed. The x-intercept changes. The y-intercept, should use a different color, shouldn't I? It's not applicable still. And the other point has been changed by being made negative. Dilations are the last one. So dilations, I'll just assume that it's positive. I'll just edit this so that n is between 0 and, say, 5 with a step of 0.1. Okay, let's look at vertical dilation. So a dilation parallel in the same direction as the y-axis. So that'll be n log x, like so. And we'll start off with 1 because that's basically neutral. 1 times log x is just log x. We'll put the vertical asymptote back to x equals 0. And we'll now have a look at the behavior. As I increase n, it looks like it's a translation, doesn't it? But have a look at the x-intercept. It's not moving. So it is stretching away from the x-axis. It's stretching parallel to the y-axis in the same direction as the y-axis. So as I increase n, it stretches away. And as I decrease n below 1, it is compressing towards the x-axis. It is compressing in the same direction as the y-axis. Okay, so it's just getting flatter and flatter. So what does that mean? That affects the other point. It affects anything else? Not much. What wasn't affected? Asymptote wasn't affected. The x-intercept wasn't affected. The y-intercept doesn't have one. The other point was affected. So you can see critically for a dilation, working out that other point is really important for scaling your sketch. Last one. Let's pop the n in here instead. Remove it from here. Bring it back to 1 to start with. And we'll pop the n in here as well. Okay, so as I increase n, it looks like it's doing the same thing, doesn't it? But what it's really doing is it's pulling itself towards the y-axis. That's really what's happening here. And if I go less than 1, it is now stretching away from the y-axis. So it's stretching or compressing in the same direction as the x-axis. Okay, so it's pulling that way or pushing that way. And that's what we're seeing. Note that the green dot here is sort of staying on its same value of 10 here, but it's just going up and down. Okay, so that's the effects there. What have we got? We've got the asymptote does not change. The x-intercept does change. The y-intercept won't be affected, and the other point is also affected. Okay, so having a look at this then, I might just pop that to the side a little bit. Having a look at this, you can sort of start to see a pattern here that when it comes to the asymptote, the only time it changes is with a horizontal translation. When it comes to the y-intercept, the only time it will change is also with a horizontal translation. If there is no horizontal translation, there is no y-intercept. It's only for a horizontal translation. The other point is always affected. So the one other point is always affected. And x-intercepts are really only not affected with reflections and otherwise are. So this table sort of gives you a sense of what should change. Okay, I am going to leave the video here, and in the next video I'll have a look at a few examples. And of course, I'll just finish by saying we looked at each transformation in isolation. Of course, there could be multiple transformations happening.